Steel box slips from the deck of a cargo ship somewhere far out in the ocean, and for a few seconds it stops being ordinary. It is no longer the same container that once waited behind a supermarket, rode on a freight train, or sat humming beside a warehouse loading dock. Now it is a floating wreck in black water. Waves slap against its corrugated sides. Air may still be trapped inside. The cargo may be dry, smashed, toxic, worthless, or somehow untouched. And before anyone on shore even realizes it is gone, the sea has already started deciding what happens next. Before the modern shipping container reshaped global trade, moving goods across the world was slow, messy, and brutally physical. Cargo did not travel inside identical steel boxes with neat serial numbers and standardized corners. It moved as sacks, barrels, wooden crates, bundles, machinery, rolls of fabric, and strange, uneven objects packed deep into the dark belly of a ship by hand. Dock workers climbed through holds with hooks, ropes, pallets, sweat, and muscle. Coffee bags could split open. Glass could crack. Machinery could arrive rusted or dented. Theft was common enough that a busy port had to treat every loading operation as both a transportation job and a security problem. The biggest problem was not always the ocean crossing, it was everything that happened before and after it. A shipment might be loaded onto a truck, unloaded at a dock, stacked in a warehouse, carried into a ship, unloaded at another port, sorted again, and then loaded onto another vehicle. Every transfer meant more hands, more delays, more chances for damage, and more money disappearing into the process. The cargo was moving forward, but the system around it was heavy, slow, and full of weak points. In the mid-20th century, American trucking entrepreneur Malcolm McLean helped popularize the modern intermodal shipping container by pushing an idea that sounded almost too plain to be revolutionary. Stop touching the cargo piece by piece. Put the cargo inside a box, then move the box itself. In 1956, a converted tanker carried early containerized cargo from Newark toward Houston, proving that a steel box could become more than packaging. It could become the basic unit of global trade. That box needed to be far more than four walls, a floor, and a locked door. It needed a body strong enough to be lifted by crane, stacked in tall rows, locked to another container, dropped onto a truck chassis, locked again, placed on a train, and lifted onto a ship without being unpacked. Its real strength came from standardization. A container had to fit cranes, rails, highways, ports, ships, and storage yards across countries that might not share the same language, but could all work with the same metal dimensions. The first container ports looked less like old waterfronts and more like a new kind of machine spread across the shoreline. Giant cranes replaced crowds of dock workers carrying individual cargo. Rows of boxes rose in sharp blocks of red, blue, grey, green, and rusted orange. Instead of loose freight disappearing one piece at a time into a ship's hold, containers slid into vertical cells or stacked above deck like a floating city built from steel bricks. That speed created a new vulnerability. A torn coffee sack inside a cargo hold was a shipment problem. A 40-foot steel container falling off the side of a moving ship became something larger. It could become a navigation hazard, an environmental concern, an insurance case, a cleanup operation, and sometimes a mystery that drifted for miles before anyone could even see it. Containers are not just placed on ships and left there. They are secured with corner fittings, twist locks, lashing rods, turnbuckles, cell guides, and carefully planned loading diagrams. The heaviest boxes are supposed to sit lower in the stack. Lighter ones ride above them. Dangerous goods require special declarations and careful placement. Each container has a known weight, destination, and exact position on the vessel. On a loading plan, a container ship is not a random pile of boxes. It is a massive three-dimensional puzzle balanced by weight, route, risk, and timing. Out at sea, that puzzle is tested constantly. A ship does not simply glide forward like it does on a map. It rolls from side to side. It pitches into waves. It heaves upward, drops downward, twists, shudders, and slams. In heavy weather, container stacks can lean with terrifying force. A wave may lift the bow, let it fall, and send a deep metallic vibration through thousands of tons of steel. Wind presses against stacked containers like a wall. If lashings are weakened, if weights are wrong, If a stack is too stressed, or if the ship begins rolling in the wrong rhythm, the boxes can start to shift. A container going overboard is rarely a clean little accident. Sometimes a single box breaks free and disappears into the spray. Sometimes an entire stack collapses like a row of falling blocks. Containers can crush each other as they slide. Doors may burst open. Refrigerated containers can rip away from power cables. Cargo can spill across the deck before anything even reaches the water. On the bridge, the crew may feel a change in the ship's motion, hear alarms, receive reports from deck inspections, or discover the loss only when conditions are safe enough to check. Once the crew knows containers have gone overboard, the accident turns into a procedure. The ship must identify what was lost, where it happened, and whether any container carried dangerous cargo. That location matters because a floating container can become an almost invisible hazard. From the deck of a smaller vessel, it may appear as nothing more than a dark line under the waves. At night, in rain or in rough seas, it may not appear at all until it is dangerously close. When a container hits the water, its fate depends on a rough mix of physics, cargo, and damage. An empty or lightly loaded container may float for a while because air remains trapped inside. A container packed with dense cargo may sink quickly, especially if its seals fail, its doors are damaged, or its walls are torn open. Some ride low in the water, showing only a narrow strip of metal. Others split open and spill the strange inventory of modern life into the ocean. Sneakers, toys, furniture, plastic pellets, electronics, chemicals, food, car parts, or raw materials meant for factories thousands of miles away. Saltwater does not wait politely outside. It finds every damaged door, vent, crack, warped seam, and twisted corner. Cardboard turns soft and collapses. Labels peel away. Wood swells. Electronics die. Food spoils. Metal begins to corrode. If the cargo floats, it can spread across the surface and travel with wind and current. If the cargo is hazardous, the situation becomes more urgent. Authorities may warn nearby vessels, estimate drift paths, watch for debris, and prepare coastal cleanup if the contents begin washing toward land. Recovering a lost container sounds simple until the ocean shows its size. A box may drift away before anyone reaches it. It may sink long before a salvage vessel can arrive. It may settle on the seafloor in water so deep that bringing it back would cost more than the cargo was ever worth. Even when the last known position is recorded, storms, darkness, distance, depth, and moving currents can turn recovery into a guessing game. Many containers are never found again. When a container sinks, it does not always become silent and meaningless. On the seabed, it can become a hard, artificial shape in a soft marine world. Mud gathers around the edges. Small animals may attach themselves to its walls. Fish may shelter near it. At the same time, whatever is inside may leak, decay, or spread into the surrounding environment. Scientists studying lost containers have found that they can alter the tiny habitat around them, not as a planned reef or useful structure, but as an accidental industrial footprint left in the deep. Back on land, the accident continues in paperwork. The shipping line, cargo owners, insurers, port authorities, and sometimes environmental agencies begin reconstructing the event piece by piece. What was inside the container? Was the declared weight accurate? Were the lashings in good condition? Did the weather exceed what the ship was prepared for? Was the cargo packed correctly? A container falling into the ocean may look like one sudden dramatic moment, but the investigation often stretches backward through warehouses, loading software, bills of lading, maintenance records, weather data, and decisions made days or weeks earlier. Modern rules have tightened because lost containers are not just private business losses. They can threaten fishing boats, small craft, coastlines, protected waters, and other ships. The most famous container losses are often remembered because the cargo refuses to disappear. Plastic toys from container spills have washed onto beaches years after falling into the sea. Ocean currents turn ordinary objects into accidental tracking devices. A rubber duck, a Lego piece, or a sneaker can travel farther than the person who bought it ever imagined. Beachcombers may find one small clue long after the ship has finished its voyage. The claims have been filed, and the container itself has vanished. A shipping container is built to make the world feel organized. It turns distance into schedules, cranes, trucks, trains, ports, warehouses, and store shelves. It makes global trade look almost predictable. But when one falls from a ship, that clean system breaks open in the water. The box becomes wreckage, evidence, hazard, habitat, and message all at once. It is a piece of the global supply chain drifting loose, reminding us that even the most standardized object on Earth still has to cross an unpredictable sea.